theme for afternoon session is Team Neo with the title Amendments to the IGC and IGF Code to approving alternative metallic material for cryogenic service. Please welcome Team Neo.
Good afternoon, ladies and gentlemen. First of all, I appreciate the lunch provided by mock-IMO assembly. And we are Team Neo, who will open the new way for the ship. We are going to talk about regulation. Then our topic is the amendments to the IGC and IGF codes to approving alternative metallic material for cryogenic service. It is literally about amending regulations to use new metallic material in the actual ship construction field. These are contents of the presentation. First, we will describe the background of our new material project, and after that, we will analyze problems of current IMO regulations and how to solve them. And finally, we will introduce our proposal and conclusion of the project at the end. So first, background. In this content, I will describe strategic directions first, and then current IMO rules such as IGC and IGF code, and which experiments and requirements are for both codes, and characteristics of existing three types of steel. First, strategic directions. Our project strategic directions is in the output number 6.1, which is the unified interpretation of provisions of IMO safety, security, and environment-related conventions. And it is in the SD6, which is to ensure regulatory effectiveness. So we propose our agenda to the carriage of cargoes and containers, which is called CCC. And after approval, we submit it to the Maritime Safety Committee, which is called MSC. And it will go to Council and Secretariat, and finally to the Assembly. Then IMO rule. Currently, there are two types of code in IMO rule, and one is IGC code, which is a safety standard for liquefied gas carriers, and the other one is IGF code, which is a safety standard for liquefied gas fuel propulsion ship. The IGC code contains specifications for LNG storage tank, and IGF code contains specifications for LNG fuel tanks. So in order to transport LNG by the ship must be constructed following these two codes. But the IGC code was amended in 1983, and IGF code was amended in 2015. Some contents of them have been revised a bit, but most of them have been used until now. So here's the thing. These following codes are required now for use as LNG storage tank steel in IGC and IGF code. These two codes strictly limit the use of the steel to 9% nickel steel, austenitic stainless steel, aluminum alloy steel, and nickel alloy steel. And plus, these requirements should be met in tensile and sharp impact test. These three types of steel have been used for a long time, even since the IMO code didn't exist. So they were easy to be listed on the code. And also, they've not had a big problem in their use so far, so they are still in the code and have been used until now. So the thing is that if the material passes all these requirements, there's no problem to be used in LNG system. However, as shown in this table, three types of steel have advantages, but disadvantages too. The most critical things of steel are weldability, economic efficiency, and corrosion resistance. As you see, 9% nickel steel has low weldability, and austenitic stainless steel and aluminum alloy steel have low economic efficiency. But what if the new material with better performance are developed? And what if they can make up these advantages of these steels? Obviously, they should be replaced to the better one. And also, most users will want this new and better one. So this is new metallic materials used in cryogenic environment have been developed before. However, they've not been used yet because there's no procedure to verify them. So there's a need for optimized process to reduce the time to approve new metallic material to use them in actual ship construction. So the IGC and IGF code are amended once every 4 years. So if a proposal is made to amend regulations for new metallic material, the IMO's IGC and IGF code entry schedule will go like this. So this is an example. In order to list new metallic material in the code in 2024, it is necessary to conform MSC in CCC7. So in short, submit a report after discussing code amendment, then the amendment in the CCC7 working group should be carried out. But now, both codes do not have a process for a code listing for new metallic material. Because of this, no new steel has ever been listed on the code. However, research on the development of new metallic material has been progressing rapidly, and the demand on new metallic material has been increasing high as well. So to demand this change and meet this change and demand, a code should be able to new metallic material when they are developed. So new process development is needed. Then to realize this change with analysis problems of current system, then the next presenter will present this problem analysis.
In problem analysis, we Team NEO have analyzed 3 things. First, why other steels, except 3 types of steel, have not been commercialized yet in current LNG system. And second, whether the 2 existing tests which are required now in IGC and IGF codes are sufficient. And third, if they are not, there is a need for additional tests for code listing. Let's move on to the first. First, reasons for not being commercialized. Why do IGC and IGF codes contain only 3 types of steel? In fact, these 3 steels had already started being used before the 2 codes came out. And there has been no big problem with using these steels. Then, for these reasons, they were easily listed in IMO codes and have been used continuously. Second, sufficiency of the tensile and sharp impact test. Why do IGC and IGF codes require only these 2 tests? Tensile test is an experiment to identify mechanical properties by applying tensile force to material. And sharp impact energy is a very basic physical property that shows the toughness of the material. It measures absorbed energy produced from the material until it is broken. Therefore, these 2 tests only require 2 properties, and other properties are just treated as recommendations. Third, need for additional tests. It's been about 30 years since the code was first developed. With the development of steel production technology, wouldn't we need additional tests to use the new metallic materials rather than existing tests? We think that we can add other tests in the code and use the new metallic materials from the results of those tests. Then, next presenter will introduce proposal and conclusion of our project based on problem and analysis.
In proposal, we Team NEO propose 4 specific solutions on problems, and we make conclusion with the example of procedure. For new metallic materials, the 2 codes are not sufficient, just like we saw. So we propose these additional experimental items. First of all, the experiment should be divided into base metal and welded joint, because the physical properties are different and the items to be evaluated are different as well. These test items are currently used by the International Association of Classification Societies to approve whether the new steels are suitable for shipbuilding or not. IOX is changing its rules and reflecting the requirement of modern times more quickly than IMO. So we suggest these test items because we think it is appropriate to bring items that reflect more contemporary situations. Even if each test item proposed in our project is met and all items are satisfied as shown in the figure, it is difficult to be listed on the IMO code because still there is no actual ship construction and operation record yet. So even though all of the test conditions are met, the safety and verification are insufficient without recording the actual ship. So it is required to record actual ship operation for a certain period. The third experiment we propose is track record. In track record, we record the date, problem, and characteristic of the ship while sailing along a certain route. So construct the ship with new metallic material and record the log of the operation for about 2 to 5 years, even though it is just on the near seas of our own country. And additionally, the NDT and the ship are regularly inspected. Then, if there is no problem with the LNG system during operation, it will be finally listed on the coast as new steel. The last experiment we propose is lab-scale tank test. When we operate the actual ship, it is true that it costs a lot. Then, considering these expenses, we can do a lab-scale tank test as an alternative. In this experiment, only LNG tank is made of new metallic materials, not the entire ship. And then, in the tank, the LNG is loaded and unloaded to check the safety. Besides that, additional tests such as microstructure, bending tests, and hardness tests are carried out to check the physical properties that reflect to verify whether new metallic materials can be used in the real LNG system. In this case, the lab-scale tank test is carried out by establishing a test period, assuming the life of the actual ship. Therefore, these 2 solutions demonstrate that new metallic materials can be used in LNG system. Like this way, we propose to amend the regulation as a process for listing new metallic materials in IMO codes when they are developed. To summary, the process of regulation proposed by Team NEO goes like this. First, evaluate the suitability of new steels that will be used in LNG system through existing and additional tests. Then, verify there is no problem in using new steels by operating the actual ship with track recordings. And also, check the safety of LNG system by lab-scale tank test. And finally, if the new steel passes these all conditions, we can add a new steel regulation in the IMO rule. This table is the example that we suggest as the conclusion. If the regulation is established through many kinds of process, we can use new metallic materials with excellent properties in cryogenic environments. These are our references. And considering current circumstances of cost and for safety, it is time to amend the regulation on new metallic material for LNG system in the cryogenic environment. Thank you for listening to our presentation.
Well done, Shikro. LNG is actually one of the hottest sector in the shipping industry nowadays, so it was very interesting. So I will take questions, so if you have any, please raise your name, please. Culture shock, please.
Thank you, Chair, and thank you for the Team NEO, your interesting presentation. But in the solution part, there was about lab scale tank test. So I just wondered that about lab scale tank test. Maybe its experimental environment is a little bit different from the actual ship operation environment. So because can be carried out on the land, right? So in that way, how your solution and proposal can handle these differences and how the proper test can be realized in the different environment for the sea.
Thank you, Chair, and thank you. We appreciate the question raised by Culture Shock, and please give me a second, and we can give you
Okay.
back. Okay, we've proposed a track record as a solution and proposed a lab scale tank test as an alternative with considering on expenses. But as you said, there's a difference in the experiment environment. Then to overcome this difference, we've considered that simulation by using FEM can be solution of this problem. So FEM is the finite element method. It is a new Mercier method for solving problems of engineering and mathematical physics. And so lab scale tank can reduce the expenses for conducting actual ship experiment, but it can't deal with dynamic factors, which can be caused during real ship operation. Then simulation of actual ship operation with FEM can check the dynamic factors. So we think that it can overcome that experiment differences. Thank you.
Thank you.
Great answer. Next question, please. Ocean 3, please go ahead.
Hi, I'm Chung-Yun Kim from Oceans 3. Thank you, Team NEO, for the presentation. My question is that, is there any real case or example when innovation was hindered or innovation was impossible due to the current regulations? Are there any new materials that were not able to be applied to the oceanic environment because of any regulations that exist?
Okay. Thank you for your question. And please give me a moment, then we give you back answer. Sorry, but did you ask the question about is there any real cases of that which is developed as new metal material?
Yes, are there any examples of new material that was developed or that is being developed but cannot be applied due to the current regulations?
In our knowledge, but I'm not sure that we can say this kind of material, but we know that there is a high manganese steel. It is proposed from the POSCO. So we think it is one of the examples of that new metal material that we proposed. So we want that high manganese material has a much better performance than existing steels, but there is no procedure to approve that new metal material. So that's why now we can't use that good performance material. So what we propose is that we want to make the way and procedure as a regulation to use that kind of new metal material in the actual ship construction field. Thank you.
All right, next question. Si Echo.
Thank you for your excuse me. Thank you for your presentation. Your topic is actually very technical, and I can't say for sure that I have understood you 100% correctly. But my question, based on the things that you have said, is that you have mentioned you wish to conduct experiments, actual experiments on board ships, on the new materials that can hold an LNG as cargo. And I'm sure you know that LNG is a highly pressurized cargo. And my question is, would it be considered safe to conduct such experiments on board? Thank you.
Thank you for your question. Then please give me a sec to prepare the answer. Okay, thank you for your question. And actually, you questioned about the actual ship experiment, right? And we call it track record. So actually, when the new material is developed, and of course we have to evaluate its safety and so on. So the first reason why we do the track record experiment, because we want to approve the safety. So also there's some, in our knowledge, there's some regular inspections in the classifications. So also our track record also follow that regular inspection in classification. So, and also it is the main additional test what we proposed. So also previous question is about like in the RAP scale test that we proposed as alternative, there's no, like it is totally different experimental environment because it is conducted on the land. But through the track record, we believe that we can verify all the factors that especially about the safety, because it is actual ship operation. So.
Thank you.
Yeah, thank you.
Okay, I will take just one more question. So if you have, please ask. Yes, please.
Thank you, Chairman, or how I can call you. I think that the real value of your proposal is that you have proposed the process instead of just some items. So you are proposing change of process to accept or to use new materials for shipbuilding. So that is your real value. And for that, I have two questions. The first one is that the acceptance criteria. You have proposed that there are some tests and land tests and experimentations and additional tests, and every test requires some kind of acceptance criteria. So, do you have any idea on what would be the acceptance criteria of each test? And the second one is that the total benefit of the proposed process. That means you are focusing on just a shipbuilder's perspective, as far as I feel, but there must be another benefits from the other stakeholders. So, is there any other benefits from others stakeholders' point of view?
I think you can select just one question because we have limited time, and then you can answer.
Thank you for your question, Judge. Then please give me a second to organize your question. Okay, we'd like to answer the second question. And we believe that it's quite obvious that new metallic material has many benefits. So, but now we already mentioned that there's already new metallic material with good performance being developed. So, but now the performance is much better than the past, and the number of test items to verify steel also has been increased. So then we believe that through the additional tests, what we proposed, then we can verify the new metallic materials safety and other factors that we should approve. Then the things that we aim is that there is a really good material outside. So we have to use that for our benefit. So, so what I want to say is, it's obvious that new metallic material has many benefits, and what we have to do is make the procedure as a regulation to use that new material in the ship, actual ship. So, yes, thank you.
Okay. Thank you very much. Well done, Shikro. You can return to your seat. Thank you.